Very good morning, students. So we are in the session 4 of work energy and power topic. In Canada, we will try to continue our discussion. Already session 3 நம்ம work energy theorem பத்தி start பண்ணிருக்கோம். Okay, so we talked about what is the basic idea of the work energy theorem. அதுக்கப்புறம் we even started looking at what are the different types of energy forms. Okay, அங்கிருந்து we came to the concept of the kinetic energy. Okay, kinetic energy, how we can see kinetic energy in our surroundings, like moving air agatum or the flowing water, all of them will have what? Kinetic energy. Okay, so the we were able to make an observation of some of the common things around us that will have kinetic energy. Okay, so in Canada we'll derive the expression for the kinetic energy. So already kinetic energy definition based pani we have got one conclusion. What is it? We are saying that kinetic energy is the energy possessed by the body by the virtue of its motion. Virtue of its motion, and so now what is the basic understanding? The energy form is going to depend upon the speed or the velocity value. But eppadi and the relation varum solittu that's what we need to see. Okay, so once we derive the kinetic energy or expression, adilende we will be able to understand. Okay va? So we'll start the derivation. We have actually two ways of deriving it. One, by using the equations of motion. Okay, so paranga, we'll consider a body. Let us say the mass of the body or m which is initially at rest, means initially at rest, and so now initial velocity 0, and a constant force is applied on the body. So initially our object is at rest, நம்ம ஒரு constant force apply பண்ணா displacement will be in the same direction தானா? Displacement also is going to be the same direction. Okay, so the force applied, let us say applied force F னு வெச்சுக்கோங்க. Then அதிலிருந்து ஒரு acceleration value எவ்வளவு? Force applied divided by mass. அதுதானா? That is what is the acceleration. Okay, so let us say the final velocity of the object is v. Initial velocity எவ்வளவு? 0. Final velocity எவ்வளவு? v. Okay, now what is the work done? இங்க பாருங்க, this is a constant force. இங்க நம்ம assume பண்றது என்ன? Constant force. Okay, if the constant force is taken, means acceleration is constant. So the equations of motion, நம்ம அந்த kinematics discuss பண்ண equations of motion, they can be used here. So what will be the displacement value? பாருங்க, what is the displacement value? It will be v square minus u square by 2a. What is the displacement value? Because it comes from which equation? V square minus u square is equal to 2as. அங்கிருந்து we will get this value of s. So பாருங்க, s will be what? Final velocity v only, so v square. Initial velocity எவ்வளவு? 0 divided by 2 times acceleration என்னது பாருங்க? f by m. So அப்படியே அந்த m மேல போய்டும். What we'll have? mv square by 2f. இது என்னது? The displacement value. Okay, work done by the force, பாருங்க, this is the constant force. Constant force means work done will be equal to what? F dot s, right? Already f and s are in the same direction, which means it will be what? F into s. அவ்வளவுதான். F into s into cos 0. Cos 0 means 1. So இங்க பாருங்க, what is this s value? Already இந்த value நம்ம கிட்ட இருக்கா? mv square by 2f. Substitute பண்ணா ff cancel ஆயிடும். What is it? Half mv square. Okay வா? So what is the work done by this particular force? Half mv square. இப்போ என்ன தெரியுமா? Let us look at the situation of the body or that object initially. Initially எப்படி இருக்கா? It is at rest, and in order to make the body to get a velocity v, the body oda velocity v ஆகிறதுக்கு, what is the work that we are doing? In order to attain velocity v, for the body, work done evla half mv square, right? So this is going to result in the energy form. What is the energy going to be called as? Because this energy is coming due to the virtue of motion dana, so we are going to call it as what? Kinetic energy. So initially it is at rest, so the kinetic energy irukadu. Finally, once we made it to attain a velocity v, right, whatever the work we are doing is going to be the kinetic energy stored in the body. So whenever we look at an object which is moving with a velocity v, so in comparison to the body at rest la what is the kinetic energy? Zero. Kinetic energy irukadu. But when it is moving with a velocity v means it will have a kinetic energy of what? Half mv square. Okay, because if you want to make it to attain this velocity, adukku we are doing a work. How much work is done by this constant force? Half mv square. So whatever the work done by the constant force is going to be in the kinetic energy form of the particular object. Okay va? So this is the derivation for the kinetic energy by using equations of motion. In the equations of motion use panna mudiyadana because we are talking about a constant force. Constant force means what? Constant acceleration. Equations of motion in kinematics can be used when it is a constant acceleration or uniform acceleration. Appada man use panna mudiyum. Okay, so this is one approach. Second is a calculus method. Difference ஒரே ஒரு difference என்ன தெரியுமா? In the previous case we have assumed a constant force, but we can consider the same situation. There is a body, அதோட mass m னு வெச்சுக்கோங்க. Initial velocity same அப்படிதான், initial velocity 0. But இங்க என்ன தெரியுமா? We are talking about a force. The force can be changing also. The force need not be constant. So இங்க என்னன்னா we cannot use the equations of motion. And the equations of motion use பண்ண முடியாது. So there is a force acting on the body which is initially at rest. So அதுல இருந்து வர displacement or the motion rate will be in the same direction as the force. அப்படிதானா? It will be in the same direction as the force. இங்க என்னன்னா we will look at a very small displacement. பாருங்க, we'll consider a very small displacement ds, okay, which will be in the direction of the force. The small work done by that force for the displacement will be what? F into ds into cos 0, which is what? F into ds. So பாருங்க, force can be expressed as what? Mass of the object into அதோட acceleration from the second law. What is it? Force can be expressed as what? Mass of the body into அதோட acceleration. So acceleration நம்ம எப்படி எழுதலாம்? In terms of the velocity. Here the information that we know is what? Initial velocity of the object is 0 and finally we are saying the object will attain a velocity v. Okay, initially the velocity is 0, finally the velocity of the object is v. That's the information. And mass of the object is m. So the force acting on the body can be expressed as what? M into a. We can also write it like what? M into dv by dt. Okay, work, small work done will be what? F into ds dana. So F badala நம்ம என்ன substitute பண்ணலாம்? M into dv by dt. Okay, so இதென்னது? இது small work done. இங்க என்ன தெரியுமா? We will do some adjustment of the differential terms. இங்க பாருங்க, dv by dt into ds. We can write it like this, dv into ds by dt. அப்படியே அந்த dt term இந்த பக்கம் கொண்டு போறோம். So just now adjusting, instead of having dv by dt into ds, we can also write it like what? dv into ds by dt. அப்படி நாம எழுதலாம். So அப்படி எழுதினா பாருங்க, what is ds by dt? Velocity, right? Rate of change of displacement என்னது? Velocity தானா? So dv into v will come, which is v dv. Okay வா? So பாருங்க, small work done by using the properties of the differential terms. எப்படி வருது? m into v dv மாதிரி வருது. So what is the small work done? M into v dv. So இதுக்கு என்ன? We are using the properties of the differential terms. Okay வா? It's a very important property. ஞாபகம் வச்சுக்கோங்க. Whenever we have the இது என்ன தெரியுமா? dv by dt means what? A. a into ds இப்படின்னு வெச்சுக்கோங்க. a into ds value can be also expressed in terms of totally velocity. என்னது பாருங்க, in terms of totally velocity it can be expressed as what? v into dv. Okay, so this is a very standard differential relation. Whenever we are having this a into ds, right, that can be expressed as what? v into dv. Okay va? So inga parunga, we are having the small work done for that displacement of ds. That value enna? dw is equal to what? mv dv. If you want to find out the total work done, adu eppadi varum? We have to integrate the expression. Inga parunga, what is the variable here? Velocity, right? Initial velocity evla 0, final velocity v, because other namakku irukra information, what is it? The information that we have is mass of the body is m, apro initial velocity is 0 and final velocity is v. பாருங்க, m is the constant, அப்படியே வெளியே வரும். Integral 0 to v, v dv. இது எப்படி இருக்கா? Integral x dx மாதிரி தானா? What is integral x dx means? x square by 2. So பாருங்க, m into v square by 2, அதுல நம்ம லிமிட் சப்ஸ்டிட்யூட் பண்ணணும். இனிஷியல் லிமிட் எவ்வளவு? 0. ஃபைனல் லிமிட் என்னது? v. So என்ன வரும் பாருங்க, w will be equal to m into v square by 2 minus 0 square by 2. 0 square by 2 சொன்னா 0 தானா? So what is it? Half mv square. So இங்கேயும் அந்த மாதிரி தான் வரும். The value will not be different. Okay, but difference என்ன? In terms of the approach we are taking to derive, அவ்வளவுதான். So what is the work done by this force? Object at initial velocity 0. அங்கலேருந்து in order to make the body to attain a velocity v, adukku what is the work done by this force? Half mv square. So same concept. This force, right, is doing work which is going to be stored in the form of kinetic energy of the body. And initially kinetic energy kadiyadu, that is at rest. So whatever the work done by us, right, is going to be stored as energy in the body because of the virtue of its motion. That is what we are calling as kinetic energy, right? So what is the value of the kinetic energy? Half mv square. Okay, so this is the derivation for the kinetic energy by using the calculus method. Okay, derivation நம்ம எதுக்கு பண்றோம்னா, we need to understand எப்படி இந்த வேல்யூ வரதுன்னு சொல்லிட்டு. Okay, otherwise we could have just given the formula and moved on. Okay, but in the calculus method of இந்த derivation நீங்க ஒரு தடவை பாருங்க, ஏன்னா this will sometimes be useful for us while solving some problems. Okay va? So this is about the kinetic energy oda value. Now whenever we are looking at the displacement agatum or the velocity or acceleration or even work, we were seeing whether this particular quantity depends upon the observer. So inga parunga, the question is, will the kinetic energy depend upon the frame of reference? Frame of reference and sonna enadhi? Simply we can also call in common language as what? Observer. Frame of reference is that kind of or technical term that we are using in physics, right? But we can also simply say it as what? Observer. So the question is, will the kinetic energy depend upon the observer? Paranga, if you have an object A irka, there is an object B, and there is an object C. Object C is at rest. Object A is moving with a speed of 60 meter per second towards the right. Object B is moving with a speed of 30 meter per second towards the right. What is the velocity of A with respect to C? C is at rest, right? Like, you know, somebody is going in a car with 60 meter per second. You are standing on the road. What will be the velocity of the car that you see? 60 meter per second, because you are at rest. But what will be the velocity of A with respect to B? B is moving. So here will come to the concept of the relative motion. Velocity of A minus velocity of B. What is it? The velocities are vectors. So direction nama account pannanom. Both are in the same direction. Both are in the same direction. So we can say this is like what? 60i. This is 30i. So what is it? 60i minus 30i. Velocity of A always another. We have to look at the velocity of the body minus velocity of the observer. other than relative velocity. What is the relative velocity value? Velocity of the body that is studied minus the velocity of the observer or the frame of reference. இங்க பாருங்க, what is the value coming as 30 வருது. Means what? If you look at the object A, அதோட velocity with respect to the C எவ்வளவு? 60. What is the velocity of the A with respect to B? நீங்க B ல இருந்து observe பண்ணா what is the velocity? We will see that the relative velocity will be only what? 30. பாருங்க, kinetic energy, what is the kinetic energy value? Half mv square தானா? What is the kinetic energy value? Half mv square. So இதுல என்ன வருது? The velocity term is coming. இது என்னது? Magnitude of the velocity ன்னு சொல்லலாம், or speed, whatever we want to call it. So because the kinetic energy term is having the velocity, magnitude or the speed, the kinetic energy is going to depend upon the frame of reference. When C is looking at A, he will record the kinetic energy of A as some value. When B is looking at A, he will record the kinetic energy of A as a different value. Why? Because the kinetic energy will depend upon the magnitude of the velocity, which will of course depend upon the observer. Okay, va? So this is about, so paranga, even in case of work also we said the same thing. Work depends upon the frame of reference or the observer. These are all possible theoretical questions. Like, we can expect some question like they'll say, which of the following quantities will depend upon the frame of reference or observer? Apdi kudutittu they can give us options. Option A work, option B kinetic energy. And the madri kudukala. When they're giving these options, right, we will be able to analyze based on our understanding and answer the questions. So we have seen that displacement depends upon the observer, velocity depends upon the observer, acceleration depends upon the observer. The work depends upon the observer. Kinetic energy also depends upon who is the observer. Okay, so this is about the dependency of the kinetic energy on the frame of reference. Now we will come to the most important part, and the work energy theorem. So work energy theorem, the main concept enna theriyuma? It is like, to put in very simple terms, conservation of energy apdi solala. So look at this. What is the work energy theorem, the main statement? This statement of the work energy theorem, right, we also call it as the basic form of the work energy theorem. The basic form of the work energy theorem. Sometime later we will see one more variety, which is the modified form. Okay, so this is the basic form. We will get the second variety also. But paranga, what is this? Work done by forces acting on a body. Ipo body irundhu vechukonga. Work done by the forces acting on the body is equal to the change in the kinetic energy of the body. Eppadi paranga, let us say there is a body, adoda initial kinetic energy Ke initial nu vechukonga. We are doing a work. Now the kinetic energy of the body might change. This relation, this is what they are talking about in the work energy theorem statement. We will try to understand this with an example first. For example, we will try to understand. Paranga, let us say the initial kinetic energy of the body or 15 joules in vechukonga. We are doing a work of 5 joules. Paranga, what will be the total final kinetic energy? 15 plus 5 evaladi? 20 dana. So already, like, you are having, there is a water tank. Adukulla already there is some 15 liters. நீங்க ஒரு 5 liters pour பண்ணா what will be the total volume? 15 plus 5 20. அப்படிதானா? So similarly, in terms of this is what the interaction between the work and energy. This is the interaction between the work and energy. Okay va? So paranga, the relation is what? Ke initial plus the work done will be equal to what? Ke final. So அப்படியே நீங்க அந்த K initial term right side எடுத்துட்டு போனா what you will get? Work is equal to Ke final minus Ke initial. What is this? Change in kinetic energy. Final kinetic energy value minus initial kinetic energy value. That is the change in the kinetic energy. So this is what is the basic form of the work energy theorem. Enadhu paranga, work done by the force acting on the body. Work done by the force acting on the body and sonna we are looking at the total work done. So say for example there are two forces acting on the body nu vechukonga. We have to calculate the work done by the first force and the madri we have to also calculate the work done by second force. And the rendu values நம்ம add பண்ணனும். That is what is the total work done. Okay. So total work done on that particular body is equal to what? And the body oda change in kinetic energy. அவ்வளவுதா. That is what is the work energy theorem concept. இங்க என்ன தெரியுமா? Energy and work. So because we are saying work done is equal to change in kinetic energy, so which means we said different types of energy reconciliative, we talked about it, but energy, right, is a physical quantity which is a property of the object. Like kinetic energy is what? The energy that will come because of the virtue of motion. And the madri potential energy enadhi, it is the energy that is associated by the virtue of the position or the configuration. Appadidana. Chemical energy enna, it is the energy that is because of the chemical composition. So the energy and work, right, they will have both identical units as well as the dimensional formula. Inga paranga, if you look at this kinetic energy, what is the rate? What is the expression for the kinetic energy? Half mv square. So units mattum nama paakala. What is it? Half is a constant. Okay, mass is in terms of kg. This is what? Meter per second the whole square varum. What is it? Kg into meter square per second square. Then this is what is joule, right, which we represent this by the symbol capital J. So SI unit of the energy is also what? Same as the SI unit of the work, which is joule. What about the CGS unit? Work or CGS unit enna? ERG, right? ERG, same. Energy will be having the same CGS unit ERG. What is the conversion? 1 erg will be equal to what? 10 power minus 7 joules dana. What is the conversion? CGS lo undu SI unit oda conversion enadhi? 1 erg will be equal to what? 10 power minus 7 joules. Okay va? Inga parunga, the dimensional formula also will be same. What is the dimensional formula for the work? What is it? ml square t power minus 2. Inga appadida. What is it? ml square t power minus 2. The dimensional formula for energy, whether it is the kinetic energy agatum or even further we will see potential energy, other types of energy also. What will be the dimensional formula? Same as the dimensional formula of the work. Okay va? So this is what is the work energy theorem. What is it? Work done by all the forces acting on the body is equal to what? Change in kinetic energy of the body. Change in kinetic energy of the body and so now what is it? Final kinetic energy minus initial kinetic energy. Avladha. Okay va? So idu base panni we will try to look at some example problems. Okay, but before we go to the examples, right, we will try to look at the interaction between work and the kinetic energy. Because remember we talked about the work, they said work can be positive, work can be negative. So what is going to happen if the work is positive? What will happen to the kinetic energy? If the kinetic energy of the body is increasing, means the work should be positive. எப்படி சொல்லலாம்? What is the work energy theorem statement? W is equal to Ke final minus Ke initial தானா? If the kinetic energy of the body is increasing, means what? Ke final oda value is higher. So நீங்க Ke final வந்து K initial subtract பண்ணா we will get what? Overall என்ன வரும்? Positive வரும், which means work will be positive. Okay va? If you have the kinetic energy decreasing, if the kinetic energy oda value is decreasing, means what? Work will be negative. Eppadi parunga, if the Ke final is less than vechukonga, let's say Ke final oda value is some 2 joules, initially is some 3 joules. Inga parunga 2 minus 3 evlo varudhu? Minus 1 dana, which means what? Work will be what? Negative. So when positive work is done, appo enna agum? The kinetic energy of the body will be increasing. So if the kinetic energy of the body is increasing, means what? We can say that work is what? Positive. If the kinetic energy is decreasing, means what? Work will be negative. Okay va? Adukku nam examples paakala. Look at this. In the vertical straight line motion, right, which will happen under the gravity. So whether the body is moving up or moving down, it will happen due to the gravity dana. When a body is projected up, means if it is going up, displacement eppadi irukum? Upwards. Gravitational force downwards dana. Mg will be downwards. Okay, so paranga, the force of gravity is in opposite direction to the motion. Motion means we are talking about the displacement. Displacement upwards. The direction of the force is what? Downwards. What is the angle between them? 180 degrees, right? So what will be the, if you take it vertically up by a value h, already naam in the value paathirukom, what is it? The work done by the gravity will be what? Minus mgh. When you take it up, gravity work done will be what? Minus mgh. Okay, so the work is negative means what? Object or kinetic energy will be what? Decreasing. This is a very common observation. Object throw panna, what you will see, as the object is going up and up, the object or kinetic energy will be decreasing. How do we know? Because the velocity will decrease, right? The velocity will totally become zero. That is what we call as the maximum height. That is what we will be calling as the maximum height. It will come down because there is a acceleration downwards. Okay, va? So when it is falling down, displacement is down, and gravitational force is also down. In this case, the work will be what? Positive. Remember, we talked about it. When you bring it down by a displacement h, displacement is downwards, the gravitational force is also downwards. So work will be what? Work done by gravity will be plus varum. Okay, so work done is positive means what? We will see that the kinetic energy of the body will be increasing. So kela varumbodhu you will see that as it is keep on coming down, the object velocity as well as the kinetic energy will be keep on increasing. Appadidana. And when it is coming down, right? So mala pogumbodhu what is the observation? When it is going up, ninga apdiye oru object throw panna, when it is going up, and the object velocity will keep decreasing. But kela varumbodhu it will be keep on increasing, right? Adu yen agudanna, because when it is coming down, the work done by the gravity is positive. So that is the reason why kinetic energy keeps on increasing. Okay, va? So this is one example that we can see on the relation between the kinetic energy and the work. So work positive means object or kinetic energy will be increasing. Work negative means kinetic energy of that object will be decreasing. Okay, va? Other example paranga. When a body is moving on a rough horizontal surface, there is a rough horizontal surface, there is an object which is moving. Okay, so in displacement we are taking to the right side. Then what will be the direction of the frictional force? What will be the direction of the frictional force? It will be in opposite direction, dana. And a friction always opposes the relative motion. Object is moving towards the right side means friction acting on the object will be towards the left side. So if you look at what is the angle between them, what is the angle? 180. So work done by the friction, it will be what? Frictional force into displacement into cos 181. Means what? Cos 180 minus dana, minus 1. So England the work done by friction is coming as negative. In the result already so because the work done by the friction is negative, as the object is going, so normally if you just move classroom on your table, you just move the book, push panna, what is going to happen? It will move for some distance, it will stop. It will be moving for some distance, it will be stopping, right? So why is it stopping? Because the friction is opposite to the direction of motion and it is doing negative work. So as a result, what will happen? The work is negative means kinetic energy of the body will be keep on decreasing. It will keep decreasing and at some point it will become zero. Okay, va? At some point it will become zero. The distance traveled by the body before it comes to rest, right? That is what we'll generally call as the stopping distance and solo. The distance traveled by the body before it comes to rest, right? The word that we use for it is what? Stopping distance. The distance after which it is stopping. Okay, va? So this is about the interaction between the kinetic energy and the work done on that object. Okay, so we will go to the examples. We'll start with very basic or simple example. There is a force 10I minus 2j minus k acting on an object during the displacement. So the force kuduthirukanga. What is the force? 10I minus 2j minus k. Displacement 2I plus j. Remember, force in the units SI unit. Displacement SI unit. Okay, so the work we can calculate. What is the work? F dot is dana. So since force is in Newton and the displacement is in meter, work will be coming in terms of the SI unit and the joules. Okay va? So what is it? What is the dot product? Product of the I components 10 into 2 plus product of the J component inga irundha parunga minus 2 plus product of the K components. Displacement la K component kadiyadu. So appadiyee the product of the K component will be 0. Inga parunga what is it? 10 into 2 evla 20, 18 joules varum. So what is the work done by this particular force? 18 joules. Okay, அப்படியே வெச்சுக்கலாம். So what is the work done here? 18 joules. பாருங்க, what is it that we need to calculate? What will be the final velocity if its initial velocity is 4 meter per second? அந்த ஆப்ஜெக்ட் ஓட இனிஷியல் velocity கொடுத்திருக்காங்க. They are asking us what is the final velocity. So நம்ம என்ன calculate பண்ணனும்? They are asking us what is the final velocity. So remember, what is the relation we will be having here? Work done is there. We have to relate the initial velocity and final velocity. அதுக்கு என்ன? The formula that we need to always think about it. Whenever we have to relate velocity initial, velocity final with work, what is the formula we have to always think about? It is the work energy theorem. So work done by the forces acting on the body is equal to what? Change in kinetic energy. இப்போ பாருங்க, initial velocity எவ்வளவு? 4 meter per second கொடுத்திருக்காங்க u. Mass is what? 2 kg. Let us say final velocity is v. That is what we have to find. So work is equal to what? Half mv square final kinetic energy minus half m u square. இங்க என்ன தெரியுமா? We can just take half m common. So work எவ்வளவு? 18 joules, right? Is equal to half into mass is what? 2 kg. v square minus u square எவ்வளவு? 4 square means 16 வரும். So இங்க பாருங்க, everything is in the SI system of unit. 18 is equal to v square minus 16. Minus 16 நம்ம left side எடுத்துட்டு வந்தா it will become what? Plus 16 தானா? So 18 plus 16 எவ்வளவு? 34. 34 is equal to v square. அங்கல இருந்து what is the v value we will get? எவ்வளவு வரும்? v will be equal to what? Root 34. Unit is going to be SI unit, meter per second. எவ்வளவு வரும் பாருங்க? Root 34 meter per second. Okay வா? It's a straight question. என்ன பண்ணிருக்கோம்? They have given us the force and the displacement கொடுத்திருக்காங்க. We are finding what? First work. So work done by forces acting on the body is equal to what? Change in kinetic energy of the body தானா? Which is what? Final kinetic energy minus initial kinetic energy. அதுல இருந்து we are able to find out what is the velocity. Okay வா? We'll go to the next question. So it's a good example. ஏன்னா இந்த மாதிரி this kind of model has already come in the past year. ஒரு தடவை வந்து an object of mass 5 kg falls from rest through a vertical distance of 20 meter. So it is falling down. கீழ வர மாதிரி. What is the vertical distance through which it is falling? 20 meters. Okay. Initially எப்படி? Rest means initial velocity எவ்வளவு? 0. And attains a velocity of 10 meter per second. So final velocity எவ்வளவு பாருங்க? 10 meter per second. How much work is done by the resistance of the air on the object? They are asking us what? How much work is done by the resistance of the air? Normal when we look at our kinematics, we say neglect air resistance. We will usually say neglect the air resistance. But we cannot neglect the air resistance. We have to consider the air resistance also. So paranga, on this object which is falling down, right? There will be gravity. What will be the forces? Gravity irukku, and there is the air resistance. Air resistance நம்ம neglect பண்ண முடியாது. In fact, they are asking how much work is done by the air resistance. பாருங்க, what is the gravitational force? Mass of the body எவ்வளவு? 5 kg. What is the acceleration due to gravity? 10. Okay வா? அப்போ what is the gravitational force? என்னது? mg தானா? What is it? 5 into 10. 50 newtons. So the object is having a displacement of 20 meter downwards. இங்க பாருங்க, what is the work done by the gravity? Object is coming down, gravity is down. Okay, பாருங்க, what is it? 50 newtons into 20 meters into cos 0. What is it? Cos 0 is anyway 1. 15 to 20 எவ்வளவு? 1000. so then is 1000 joules. So work done by gravity எவ்வளோ 1000 joules. Okay, இங்க பாருங்க, we don't know what is the work done by the air resistance. In fact, அதுதான் நம்ம calculate பண்ணணும். So what is the relation we can think about? ஏன்னா we know the initial velocity. Initial velocity நமக்கு தெரியும், final velocity தெரியும். So what is the relation we have? Work energy theorem தானா? What is the relation we are having? Work energy theorem. So work done by all the forces. All the forces means what? Gravity varu plus air resistance. So work done by all the forces is equal to change in the kinetic energy of the body. So we will just erase this diagram. So work done by all the forces is equal to what? Change in the kinetic energy of the body. இங்க பாருங்க, what do you mean by work done by all the forces? Work done by all the forces, what is it? Work done by the gravity, that is 1000 joules, plus work done by the air resistance is equal to what? Change in kinetic energy. Change in kinetic energy means what? Half into mass level of 5 into final velocity வந்து பாருங்க 10 meter per second. Initial velocity எவ்வளோ 0. என்னது 0 square is 0 தானா? 10 square எவ்வளோ 100. 5 into 100 by 2 எவ்வளோ வரும்? 250 வரும். SI unit joule. So இங்க பாருங்க, 1000 joules plus work done by the air resistance is equal to 250. அப்படியே நீங்க அந்த ரைட் சைடில் எடுத்துட்டு போனா it will become what? Negative. So work done by the air resistance எவ்வளோ? 250 minus 1000, that is equal to what? Minus 750 joules. ஏன் நெகட்டிவ் வருது தெரியுமா? Because the object is moving down, but air resistance, it's like the drag force. Air ஆகட்டும் or any fluid, right, they will exert the drag force. Drag force will be always opposite to the direction of motion. So object is coming down means air resistance will be what? Opposite, which means it will be upward. Like even if you are going on a bike ride, if you are going forward means what is the air resistance you will feel? It will be opposite direction. அப்படிதானே இருக்கும். So that is the reason why the work done by the air resistance will be coming as what? Negative. பாருங்க. So what is the answer for this? Work done by the air resistance எவ்வளோ? It is what? Minus 750 joules. The value is minus 750 joules. Okay va? So this is about it's a very important question. Okay, and the model is already okay. So look at another question. This is almost similar, but whatever small difference irka, we will look at what it is. A block of mass 30 kg is being brought down by a chain. So enadha parunga, we are bringing the body down with the help of a chain. நீங்க அப்படியே அந்த 30 kg mass நீங்க ரிலீஸ் பண்ணா it will fall under the gravity. It will fall with acceleration downwards. இங்க அப்படி கிடையாது. We are bringing it down by using a chain. If the block acquires a speed, see acquires a speed and சொன்னா what is it meaning? அதோட initial velocity 0. அங்கல it is acquiring. ஓகேவா? So initial velocity எவ்வளவு 0. So initial velocity எவ்வளவு 0. Okay. Final velocity என்னது? 40 centimeter per second. இங்க பாருங்க, they are giving in terms of centimeter. So 40 centimeter per second means we can convert this into what? SI unit. 0.4 meter per second வரும். ஓகேவா? So while dropping down by 2 meters, so downward displacement of 2 meters, find the work done by the chain during the process. இங்க என்ன தெரியுமா? There is gravity. Gravitational force எவ்வளவு பாருங்க? Mass is 30 kg and g oda value enna 10. So gravitational force is 300 newtons. So work done by gravity inge appadidana. So here we are considering two forces. What are the two forces? One is the force acting on the 30 kg block because of the chain. Adu eppadi irukku theriyuma? Because we are slowly releasing the block, right? We are slowly releasing the block. The force acting on the block because of the chain will be, it's like a tension. எப்படி ஒரு டென்ஷன் ஃபோர்ஸ் மாதிரி, it will be into the chain. Okay, upward இருக்கும். So இதுல இருந்து we can get some conclusion. என்னது? Because the force due to the chain is upwards and the displacement of the block is down. அதனால என்ன வரும்? The work done by the chain will become as what? Negative. Work done by the chain will become as what? Negative. ஏன்னா because the chain force is upwards and the block is moving down. Okay, so we'll see what is the final answer. Work done by gravity எவ்வளவு வரும் பாருங்க. First of all, gravity is down அந்த மாதிரி displacement also downwards, right? 2 meters it is moving down. So work done by gravity எவ்வளோ? Force into displacement into cos 0. So what is it? 300 into 2 எவ்வளோ? 600 தானா? That is the work done by the gravity. Okay. So what is the work energy theorem? Work done by gravity plus work done by the chain is equal to what? Change in kinetic energy, means half into m ever 30 into what is the remaining thing? V square minus u square. So u ever initial velocity 0, v is what? 0.4. So 0.4 square minus 0 square. 0 square means 0 only. 0.4 square பண்ண என்ன வரும்? 0.16 வரும். So half into 30 into 0.16. Half into 30 into 0.16. நீங்க divide பண்ணா what is it? எவ்வளவு வரும்? 0.08 வரும். 30 into 0.08 எவ்வளவு தெரியுமா? 2.4. What is 30 into 0.08? It's like what? 3 into 0.8. That is what? 2.4 தானா? Okay. So பாருங்க, left hand side என்ன இருக்கா? 600 plus left side என்ன இருக்கா? 600 plus the work done by the chain. LHS என்ன இருக்கா? 600 plus work done by the chain. அதுதானா? RHS ல what is the term? Final simplified term என்னது? இதோட final value என்ன? 2.4 தானா? So 2.4. So இந்த 600 அப்படியே நம்ம right side எடுத்துட்டு போலாம். So what is it? Work done by the chain force is equal to what? 2.4 minus 600. That will be what? Minus 597.6 வரும். Minus joule. Why it is minus? Because chain force is up, displacement is down. That is the reason why work done by the chain force also will be coming negative. Okay. So what is the work done by the chain force? Minus 597.6 joules. Okay va? Another question paranga. This is a question that has come in the 2009 paper. A body of mass 1 kg is thrown upwards. Everybody, we are throwing it up with a velocity 20 meter per second. So கீழ இருந்து நம்ம throw பண்ணும்போது what is the velocity? Initial velocity எவ்வளவு பாருங்க? 20 meter per second. It momentarily come to rest after attaining a height of 18 meters. Means 18 meters it is going up. It momentarily comes to rest. Momentarily comes to rest and சொன்னா what is it? Final velocity எவ்வளவு? 0. How much energy is lost due to the friction? என்ன கேக்குறாங்க? What they are asking? How much energy is actually lost due to the friction? இங்க பாருங்க, the understanding we have is what? Initial velocity தெரியும், final velocity we know, mass of the body அது என்னது? 1 kg. G ஓட வேல்யூ என்ன? 10 meter per second square. இங்க பாருங்க, there will be weight acting on the body, gravitational force. What is it? Mass is 1, G oda value is 10, which is what? 10 newtons. So when it is going from initial point to the final point, right? Paranga, what is the work done by the gravity? The object is going upwards. The object is going upwards, right? Which means what? Work done by gravity will be what? In this case, negative. And the object is moving up and the gravity is acting down. Okay. So vertical upward displacement 18 meters. Force is down 10. So 10 into 18 into cos 180 varum. Why cos 180? Because the angle between the force is down and the displacement is up. So paranga, what is it? Minus 180 joules. So work done by gravity evala? Minus 180 joules. And here they are saying, you know, find the energy lost due to the air friction. Means we have to consider the air resistance or the air friction. So we will also have work done by the air resistance. We will also have work done by the air resistance. Okay, we have to calculate that. The value we have to calculate that. Okay. So if we calculate what is it? We have the work done by the gravity, which is minus 180 plus work done by the air friction, that will be equal to what? Change in kinetic energy தானா. இங்க பாருங்க final kinetic energy எவ்வளவு 0 because it is topmost point ல it is attaining momentary rest, means final kinetic energy என்னது 0. so final kinetic energy minus initial kinetic energy என்ன half into mass எவ்வளவு 1 into v square, so 20 square. okay வா. so பாருங்க what is it that we will have? என்ன பாருங்க left hand side la what is it? minus 180 plus work done by the air friction is equal to what? right hand side la minus 400 by 2 which is minus 200. so work done by the air friction is equal to what? அப்படியே நீங்க அந்த minus 180 right side la எடுத்துட்டு போனா it will become what? plus 180 பாருங்க. so minus 200 plus 180 ஆகும். so what is minus 200 plus 180? இது minus 20 தானா. so work done by the air resistance is what? minus 20. அது நம்ம இன்னொரு விதமா சொல்லலாம். எப்படி? the energy lost due to the air friction is what? 20 joules. so work done by a particular force is positive, what we'll say? the energy gain because of the force is what? this much. if the work done by a force is negative anu vechukonga, then what we'll say? the energy lost because of the force is this much. so what is the answer? Paranga, what is the answer? the energy lost due to the air friction, what we have to say? it is what? 20 joules. so whenever a force is doing positive work, we'll say that much amount of energy is gained because of the particular force. if the work done by a force is negative vechukonga, then we'll say that much amount of energy is actually lost because of the force. inga paranga work done by the air friction evlo varudhu? minus 20 varudhu. so then what we'll say? 20 joules of energy is lost because of the air friction. okay va. so this is the question that has come in the 2009. again edu based panni? based on the work energy theorem. Another question paranga, this is a very important model. it has come in the 2006. look at this. a body of mass 3 kg is under a constant force. okay, so constant force nu sonna adula irundhu vara acceleration also will be what? constant. the body is under the influence of a constant force which causes a displacement s. அதோட equation கொடுத்திருக்காங்க. so what is the displacement? s is equal to 1 by 3 t square, where t is in seconds. work done by the force in 2 seconds. so இந்த மாதிரி மாடல் என்ன தெரியுமா? they will give us the displacement function in terms of time. இது ஒரு standard model of question. they will give us the displacement function in terms of time. கொடுத்துட்டு they will ask the work done for some time interval. இங்க பாருங்க the work done by the force in 2 seconds means t is equal to 0 இருந்து up to t is equal to 2. they are asking us to calculate the work done from t is equal to 0 to t is equal to 2. they will also give us the mass. இங்க என்ன பாருங்க mass எவ்வளவு? 3 kg. இப்படி ஒரு ப்ராப்ளம் வந்து வெச்சுக்கோங்க, then this is the approach. நீங்க இது எப்படி சால்வ் பண்ணணும்னு சொல்லிட்டு you don't need to really bother about it. ஏன் தெரியுமா? the moment they give us the displacement function, இங்க என்ன நமக்கு displacement function இருக்கா, நீங்க அப்படியே இதோட டெரிவேட்டிவ் எடுத்தா what you are going to get? என்ன வரும்? what is the derivative of the displacement function? velocity தானா? so பாருங்க we will take a derivative of this function 1 by 3 into t square. 1 by 3 அப்படியே வெளியே வரும், constant. derivative of t square அது என்னது? 2t தானா? so what is it? velocity function நம்ம கிட்ட வருது 2t by 3. அவ்வளவுதான். once we have the velocity function, right, அவங்க என்ன கேக்குறாங்க? work done by the force in 2 seconds. that is the only force, right? now work done by the force will be equal to what? change in kinetic energy, right? from the work energy theorem, what is the work done by the force? change in kinetic energy. அவ்வளவுதானா? so இங்க என்ன தெரியுமா? this particular type of question can be asked for a constant force or even for a variable force. ரெண்டுத்துக்கு நம்ம இந்த மாடல் யூஸ் பண்ணலாம். ஏன்னா very simple. they will give us generally they will give us the displacement function in terms of time. they will give us the displacement function கொடுத்துட்டு they will ask what is the work done between 0 to 2 seconds or 0 to 3 seconds அப்படிதான் வரும். ஸோ அங்கே நம்ம என்ன பண்ணணும், ஃபர்ஸ்ட் அப்படியே அந்த டிஸ்பிளேஸ்மெண்ட் ஃபங்க்ஷனோட டெரிவேட்டிவ் நம்ம எடுக்கணும். டெரிவேட்டிவ் எடுத்தா வில் கெட் வெலாசிட்டி. இங்க பாருங்க வெலாசிட்டி ஃபங்க்ஷன் நம்ம கிட்ட இருக்கா. I will put the initial velocity. What is initial velocity? T ஓட பிளேஸ்ல நம்ம 0 சப்ஸ்டிட்யூட் பண்ணோம் அப்படிதானா, because we are starting from 0 means the time ஓட வேல்யூ நம்ம 0 சப்ஸ்டிட்யூட் பண்ணோம். சப்ஸ்டிட்யூட் பண்ணா what you are going to get பாருங்க, t0 போட்டா it will be what 0. அப்புறம் ஃபைனல் வெலாசிட்டி எவ்வளவு, up to 2 seconds, right? T is equal to 2 நம்ம சப்ஸ்டிட்யூட் பண்ணா it will be what 4/3. everything is in terms of the SI unit. so என்னது 4/3 meter per second. Work done by the forces acting on the body is equal to what, change in kinetic energy, half into m into final velocity square, which is what 4/3 the square minus initial velocity அதோட 0. so half into 3 into 4 square எவ்வளவு 16, 3 square எவ்வளவு 9. so பாருங்க 3 1s are 3 3s are 2 1s are 2 8s are என்னது 8/3 அவ்வளவுதான். so what is the work done by the force, 8/3. இது ஒரு ஸ்டாண்டர்ட் மாடல் ஆஃப் கொஸ்டின். ஞாபகம் வச்சுக்கோங்க. what is it, they will give us the displacement function. இங்க என்ன, we are having the force to be constant, but the force need not be constant. அங்கேயும் same procedure தான். what is it, they will just give us some displacement function கொடுத்துட்டு they will ask us what is the work done. அப்ப நம்ம என்ன பண்ணணும், அந்த displacement function எடுத்துட்டு அப்படியே நம்ம differentiate பண்ணா we will get velocity. so depending upon the time they are asking, right, let's say in some other question they are asking from t is equal to 0 ல இருந்து t is equal to 5 seconds ன்னு கேக்குறாங்க வெச்சுக்கோங்க, then we will get the initial velocity, final velocity, use the work energy theorem அவ்வளவுதான். work energy theorem யூஸ் பண்ணா அதுல இருந்து we will get what, we will be getting what is the work done by the particular forces. ஓகேவா. so this is the approach that we need to take. அடுத்த இன்னொரு क्वेश्चन பார்க்கலாம், because this is an important model, right? we look at one more question on this. இங்க பாருங்க, displacement of a particle mass 2 kg varies with time. இங்கேயும் அப்படிதான் same. they are giving us what, displacement function கொடுத்திருக்காங்க. what is it, 2t square minus 2t plus 10. find the total work done on the particle in the time interval t is equal to 0 ல இருந்து t is equal to 2. same தானா. what is it, first we have to take a derivative of this function, 2t square minus 2t plus 10. எடுத்தா என்ன வரும், first நம்ம இந்த derivative split பண்ணலாம். derivative of 2t square minus derivative of 2t 10. derivative of constant எவ்வளவு 0. so இங்க பாருங்க derivative of 2t square 2 அப்படியே வெளியே வரும். derivative of t square எவ்வளவு 2t. இதுல derivative of 2t 2 வெளியே வந்தா derivative of t is what 1 அவ்வளவுதான். so this is the velocity function. என்னது பாருங்க 4t minus 2 அதுதான் velocity function. so இங்கல இருந்து வர velocity function என்னது 4t minus 2. ஓகேவா. so இந்த மாதிரி எல்லா क्वेश्चंसக்கு அப்படிதான். what is it, first we are going to get the velocity function. இப்போ நம்ம என்ன பண்ணணும், we have to get the initial velocity value and final velocity value. இங்க பாருங்க initial velocity ன்னு சொன்னா what is it, t ஓட பிளேஸ்ல நம்ம 0 t பதிலா நம்ம என்ன சப்ஸ்டிட்யூட் பண்ணனும், 0 சப்ஸ்டிட்யூட் பண்ணனும். so சப்ஸ்டிட்யூட் பண்ணுங்க. இந்த 0 போட்டா என்ன வரும், the velocity will be coming as what, minus 2. minus represents the direction part. ஓகேவா. final velocity எவ்வளவு வரும் பாருங்க. what is the final velocity, up to t is equal to 2 seconds means 4 into 2 minus 2. என்னது பாருங்க 8 minus 2 எவ்வளவு 6. so means that the velocity is changing its direction. velocity is not having a constant direction, velocity is changing its direction. okay, that's why it is minus initially and plus finally. okay, so இப்ப என்ன, work done by the force is equal to what, change in kinetic energy அவ்வளவுதானா. so half into m is what 2 kg into v square means what 6 square minus u square. so 2 2 cancel ஆயிடும். 6 square means what 36 minus இது என்னது பாருங்க minus 2 நீங்க ஸ்கொயர் பண்ணா it will become what plus ஆயிடும். minus 2 square is also what 4 only, right? so 36 minus 4 எவ்வளவு 32. everything is in the SI system of unit. so that is the reason why the work done will be coming in terms of what, coming in terms of the SI unit, joules. Okay, va? So this is how we'll approach these kind of questions. It's a standard model of question. What is it? They will give us the displacement function. They will ask us what is the work done. In fact, in past year questions, at least they have asked this same model of question 2 or 3 times. Okay. Now, problems will include because we have seen one past year, we are seeing one more general problem. Same method. Okay. Maybe when you are reviewing the past year questions, right? Check same model, right? They will give us the displacement, they will ask us the work. And the displacement function first number differentiate panna, we will get the velocity. Okay. So using the velocity formula, we will calculate initial velocity value and final velocity. Then we will use the work energy theorem. So these are some of the kind of problems we can see on the basic form of the work energy theorem. Okay. We look at some standard results. Derive the stopping distance value of a body moving on a horizontal surface using work energy theorem. Stopping distance and already so if there is a object which is having a velocity v, it is moving on a rough horizontal surface. Friction force will be acting in the opposite direction. Moving on horizontal surface means vertically motion irukadu. So normal reactional value and force balance mg. So frictional force will be equal to what? Mu into normal reaction, which is what? Mu into mg, the frictional force value. It is moving a distance, yes, till it comes to rest. That is what you call as what? Stopping distance. So final velocity 0. We are going to use the work energy theorem. Work done by the frictional force. So frictional force is left side, displacement is right. So work done by the frictional force will be what? Mu into mg into displacement of s into cos 180. Why cos 180 will come? Because the angle between them is what? 180 dana. The object is moving to the right. Friction is to the left. So paranga, what is it? Cos 180 minus 1. So minus mu mg into s. This is the work done by the friction. What are the forces acting on the body, on that object, right? What will be the forces acting on that object? Other than friction, we have gravity irka. And the mother normal reaction irka. Other than friction, what do we have? Gravity is there and then normal reaction is there. But the object is moving along the plane. When object is moving along the plane, right, work done by the normal reaction is 0. Since object is moving along the plane, and work done by gravity that is also 0. Why? Because it is moving horizontal. Gravity is vertical. What is the angle between them? 90. So there is no vertical displacement. Vertical displacement kadayadu. It is moving horizontal. So work done by gravity is what? 0. So which means 3 forces are acting on the object. One is friction, second is gravity, third is normal reaction. Work done by normal reaction is 0. Work done by gravity is 0. Where we'll have work done by friction force mattum. So the total work done is what is it? Minus mu mg into s. So total work done will be equal to what? Change in the kinetic energy. Change in kinetic energy final kinetic energy is 0. Finally it is coming to rest dana. Finally comes to rest. Minus initial kinetic energy half mv square. V is the initial velocity. Okay va? Minus minus cancel pannala, mm cancel pannala. So the s oda value varum parunga. V square by 2 mu g. This is a standard result. Okay, what is it? Stopping distance formula. See, this we can do by using kinematics also. Kinematics we will consider the retardation in the friction force opposite direction irka. So we will consider what is the retardation coming by using the equations of motion, right? By using the equations of motion we can find the stopping distance. But here we are deriving the stopping distance by using what? by using the concept of the work energy theorem. Here we are finding the stopping distance by using the concept of the work energy theorem. Okay va? And the madri we can also look at this special case of an object which is tied to the rope. Paranga, we are tying an object to the rope, so we can consider it like a stone or something, and rotating in a horizontal circle. It is rotating in a horizontal circle. And a vertical circular motion பத்தி தனியா நம்ம டிஸ்கஸ் பண்ண போறோம். இங்க என்னது is a horizontal circle. So explain how for an object tied to a rope rotating in a horizontal circle kinetic energy will be conserved. என்ன கேக்குறாங்க, எப்படி, how the kinetic energy will be conserved. இங்க பாருங்க, on this object which is rotating in the horizontal there will be tension force. நீங்க ஒரு rope type பண்ணி நீங்க rotate பண்ணா there will be tension. எப்படி, tension will be always acting towards the center of the circle. அதுக்கு அப்புறம் there will be weight. The object is going in the horizontal plane. Vertical displacement கிடையாது. Which means what? Work done by gravity எவ்வளவு? 0. Vertical displacement கிடையாது. So அதனால work done by gravity will be at 0. இங்க பாருங்க, the displacement at any time will be along the tangential path. நீங்க ஒரு small displacement எடுத்தா it will be along the tangential. Tension force in the rope is towards the radial direction. What is the angle between them going to be? 90. So at any instant, right, the angle between the force means we're talking about the tension force, and the displacement is 90. What is the 90? So if the angle is 90 means what will be the work done? For that small displacement, what is the work done? 0 dana, because tension into ds into cos 90 varum. So adanal work will be 0. So work done by the tension force, right, will also be 0. Only two forces we are not considering. Inga parunga, we are not considering the air resistance. Idhula nama air friction consider பண்றது கிடையாது. Okay, so the only two forces we are considering are what? One gravity, ரெண்டாவது tension. So work done by the force is equal to 0, which means what? Change in kinetic energy is 0, which means K final order value will be K initial. So that is what we call as the conservation of the kinetic energy, because if the kinetic energy is remaining constant means what? We can say kinetic energy is actually conserved. But vertical circular motion appadi kedaiyadu. We will see that there will be a difference when it comes to the vertical circular motion. Adu pathi nama thaniya discuss panna porom, but this is about the case of the horizontal circular motion of a body tied to a rope, neglecting the air resistance. Normally nama air resistance irukum. Air resistance nama edutha, what is going to happen? Air resistance is a drag force. It will always do negative work. So adanala we will see that kinetic energy of the body will keep decreasing over a period of time. That is what practically we will see. Okay va? So this is another standard result that we can see based on the basic form of the work energy theorem. Next class we will start with the idea of the potential energy and how we will modify the work energy theorem statement by using the potential energy concept. Okay va? So that we will see in the next session.